Hello, ladies and gentlemen. Welcome to Chapter 5. Chapter 5 deals with the idea, a lot of systems of equations. And we'll talk about this a little bit in class here. But systems of equations are essentially two equations or more, two or three or four equations that have variables that have variables in common. And we're going to have, so if there's two equations, you're going to have two variables. Three equations, three variables. Four equations, four variables, and so forth. What these equations do is they relate similar quantities to each other. And what we want to try and do is we want to try and find the solution for those equations. The solution is the value that makes both equations true at the exact same time. And that's usually the intersection value or intersection point between the two equations. And that's big for us when we're going to talk about graphing them today. When we deal with systems, the best real world examples, probably if you took anything with Mr. Adams in any ag classes, you do a lot of systems of equations when you're trying to figure out combinations for feed or mixtures or anything like that. That's where these systems of equations come into play. So we're going to talk about some examples here, and what we're going to do is we're going to solve by graphing. The book also says that you can make a table, and we'll talk a little bit about that more in class, not here on the video. But why we reviewed graphing at the beginning of class or beginning of the week, and here we are. So we have right here in this example here, in this first group, this is our system. Okay, we've got y equals -4 plus 2x and y equals 4 minus 2x. We see we have two equations, we have two variables, x and y. And so what we're trying to figure out is where or what value for x and y gives us true situations in both equations. Okay, so we'll start just by graphing this first equation, and it starts at -4, so we've got a dot here at -4, and then the slope is a plus 2x, so that means it's going to go up 2 and then to the right 1 each time. And if you notice here, when you graph systems of equations, you want to make, in this first line that you graph, you want to make as many points as possible, because what's going to happen here is these points that you're making, we're looking for the intersection point. So if you've got all these points made up, then we can easily determine where they intersect based off of this point. Okay, so that's that first equation. What you can do then from there is you can lightly draw a line through these here. So you've got a line. Obviously it'd be straighter for you because you'll use a straight edge. So you've got this line, that's the first line. So now here the second one, we've got y equals 4 minus 2x. So it's going to start here at 4, and since it's a minus 2, it's going to go down 2 and right 1, down 2 and right 1. Now if you see here, this blue point here is overlapping the red. It means it intersects. So we don't need to go any farther at all. Okay, this line here, okay, it'll go up this way and it'll go down that way. But we don't need to graph anymore because we already found that intersection point. That intersection point's right here. Okay, and that intersection point is the value, the x value is 2 over 2, and the y value is 0. So this 2 comma 0 is our answer, and that's how we write answers for systems of equations. We write them as an ordered pair. What we have is if we put 2 comma 0, so we have 2 comma 0 for our values. We have y is equal to -4 plus 2x, and y equals 4 minus 2x. If we put these values into each equation, so 0 goes in for y, and we have equals -4, or -4 plus 2 times 2, we get 0 equals, this is -4 plus 4, so we got 0 equals 0, which is a true statement. What we have here on the other one then is we have 0 is equal to 4 minus 2 times 2, and we have 0 is equal to 4 minus 4, so 0 equals 4 or 0. And that's also a true statement. So this is what it means when I say both statements are true. Any other point that we put in, it could make this first equation, this first equation, it could make that true, but the other one would be false. Or the second one would be true, and the first one would be false. So that means, when I say false, we have 0 equals 1, or something like that. So that's what I mean. That's what it means when we say, looking for something that's true. It makes both equations true at the exact same point. So now, if we look at the second example, we're going to do the same process here for this second example. Now, this first equation here, we've got y equals 1.5x. We have y equals 12 minus 2.5x. This first equation, if we notice, there is no first value or a value that has a number by itself. So that's an implied 0. So our first point is going to be at 0, 0. And then it's going to go up and over 1.5 each time. So it's going to go up 1.5 and over 1 each time. And we continue this. We can make our dots as far as possible on the graph. We go back the other way because we don't know where our graph's going to intersect. It could be in positive values up here. It could be down here. So we don't know. So that's why we have to make as many points as possible in both directions. So now we look at this next one. It starts at 12. So it's going to start up here. It's going to go down 2.5 each time. So it's going to go down 1, 2.5, 1, 1, 2.5, and it's going to go down 1, 2.5. Well, it looks like we've got our intersection point. Our intersection point's right there. That value here is the x value is 3. The y value is halfway between 4 and 5. So that means the y value is 4.5. Okay, so and then we could do the same checking process if you wanted. That's not mandatory. I was just showing you that to show what happens. But that is how we graph equations and we get our final answer. Answer's always got to be in an ordered pair. Okay, so take a look at this. Make sure you try it. If you have any questions, let me know.